and welcome to Scope. Today we're getting out of the bunker so we can get into some extreme environments.
Mars, our neighbour planet. We've been in the dark about this red dusty world for so long. NASA currently has a rover on Mars, but it's unable to do a lot of the important research on its own without an astronaut. So what's the next step in discovering the secrets of our red neighbour? G'day, I'm Joel.
And I'm Daniel.
And this is Rovey, our Mars Rover.
Rovey is a functional vehicle that we have built with our team of 15 people for the University Rover Challenge. This competition invites teams from all over the world to create a Mars rover. We do this so we can help better further technology and research for future Mars exploration. The competition is held in Utah at the Mars Desert Research Station to simulate the surface conditions of Mars. We do this so we can get a better idea of what Rover can do and what improvements we need to make him even better.
Rovey was one of 36 vehicles chosen to prove that he could tough it out on Mars. In any terrain and any weather.
And we're the first team from Australia ever to compete.
First up, Rover needs to be rugged and reliable to take on the terrain of Mars. He has a 360-degree camera up front, which he uses to map out the best routes through the terrain. He's autonomous too, which means we can program a GPS location into his system and then he'll navigate and drive his own way there without our help. He also has a LiDAR, which uses lasers to scan the terrain for obstacles like rocks in his path. That way, Rovey can go around things that might damage him or make him crash.
And Rovey has a special drill system which allows us to collect soil cores from deep below the Martian surface. Rovey's drill is hollow in the middle, so it collects soil cores down to 20 centimetres deep when Rovey drills into the subsurface. NASA's current Mars rover is unable to do this, but scientists believe we might find important clues beneath the surface, like evidence of water or even Martian microbes.
Rovey also has a robotic arm that's used for collecting samples like rocks and using tools. His wrist can also rotate 360 degrees, which a human wrist definitely cannot do. He's got a camera on his arm so we can see closely what he's collecting for us. He's also able to measure important properties about the Martian atmosphere, including air temperature, humidity, and pressure, critical to the search for water and life. But how do we control Rovey?
With these VR goggles and these controllers. We can see exactly what Rovey sees in full 360 degrees. And check this out. To make him reverse, we can just turn around while wearing the goggles and he'll know to reverse. Rovey was designed to be operated alongside an astronaut on the surface of Mars. Of course, it's still years before we send the first people to Mars, but competitions like the University Rover Challenge help improve research and technology so that future missions to Mars can be as successful as possible.